On to part B, and we are trying to graph a transformation of the cosine function. Let's talk about this negative actually up here first. Okay, so let's think about what this will do to the cosine function. We're going to scoot over here a little bit. So up above, we have, this is y equals cosine of x here. And it's just one period of cosine of x. And then what we will have down here is I want us to sketch in y equals minus cosine of x. So again, y equals minus cosine of x. So our first y value up here is 1. Well, if you multiply that by minus 1, well, we'll end up with minus 1. The next quarter point was at 0, right? Well, if you multiply that by negative 1, you get 0. We go to the next quarter point at pi. The y value is minus 1. Well, if you multiply minus 1 by minus 1, you get 1. And again, I keep multiplying by minus 1 because we have minus cosine here. All right, if you multiply 0 by minus 1, you get 0. And if you multiply 1 by minus 1, you get negative 1. Okay. And if I connect all these dots, we'll see that this was just a reflection across the x-axis. So that's all that negative sign did, is it just flipped our graph over. Now, technically, when we go to write in our amplitude here, we won't say minus 2. We'll say our amplitude is just 2. But we don't want to forget that that negative sign is here. And just to be general about this, I'll say vertical reflection. Next on our list, the next easy one kind of to look at here is this. So plus, last time we had plus something, but now we have minus. So this is going to scoot our graph down. Just write that in here. Okay, so this is just a vertical shift down 1 unit. And these two things combined are going to help us set up the y-axis. So let's do that. So we're going to scoot the center of our graph down 1 unit, or the center of the wave down 1 unit. And then we still need to be able to go down 2 more units from there. So we need to be able to go down all the way to minus 3. So let's just split our positive y-axis into 3 pieces, and we'll do the same with our negative y-axis. So there's the top, and then again thirds. So probably somewhere in here. In here. Okay. So our y-axis is all set up here now. Let's go and set up the x. Okay. I think we're going to need a little more information to do that, though. Let's start thinking maybe about the period. So remember, the period is 2 pi over b. And b for us is the number in front of the x, which is 3. So there's the period. Next thing is we could find the spacing. As soon as you have the period, you can always find the spacing. How far do we want to put these tick marks apart? So that's going to be 2 pi over 3, and then all that over 4. Okay. Right, we want to split it into 4. And so this just turns into 2 pi over 3. times, right? If you wrote this 4 here as a 4 over 1, you could flip and multiply. I'm just going to leave it as 4 here, though. And then we simplify, and we get, looks like pi over 6. We have one thing left to compute, and that is our phase shift. Let's find that. Don't forget, though, that our phase shift is just the horizontal shift, how far we're going to shift our graph left or right. And there's actually two ways to find this. We'll first use that little formula, C over B. Remember, C is always the opposite sign of what you'd think here. So C is actually minus pi over 2. And then this is all over B, which is 3. And this is going to give us minus pi over 6. Now, just as a reminder again, why C is the opposite sign of what you would think, well, one of them is when we wrote what C was, it was minus C. Okay, so if we have plus here, it's going to change the sign. Now, another reason is we could think about what we know from pre-calc 1. I'll erase this work here in a minute just because we'll be running out of space here. But if you were to take this equation and do a little bit of factoring, we could see what that horizontal shift would be. If I factor a 3 out here, okay, we get 3 times x plus pi over 6. And you can verify that this is right. If I distribute that 3 back through, I'll get 3x plus pi over 2. So this is just another way that we could have written the equation that we started with. And the key here really is that x plus pi over 6. You might remember that if you were to take, say, just some function, f of x, okay, and then if you were to do f of x plus pi over 6, these two graphs would look exactly alike, other than this one would be shifted left pi over 6 units. Okay. So our phase shift of minus pi over 6 is just telling us, well, let's start minus pi over 6 units to the left. Okay, and we'll do that. That's the very first point we'll put on our x-axis. Then we'll use our spacing to fill in the rest. And our spacing is pi over 6, so that's helpful to know that too. Let's see. Let's call this minus pi over 6. And we're just going to keep adding pi over 6's. If you add pi over 6 to this, you end up at the origin. We don't need to put a tick mark there. You add another pi over 6, and we just end up at pi over 6. Add another pi over 6, we end up at pi over 3. Add another pi over 6, then we're at 3 pi over 6, which is pi over 2. And then 4 pi over 6, which is 2 pi over 3. And then 5 pi over 6. And we'll just stop there for now. We'll see if this is enough here in a minute. Let's also sketch in where the center of the wave has ended up. Since we have that vertical shift of -1, this is where the center of our wave is going to be. Okay. Again, you don't have to sketch this. This is just really helpful when you first start doing this. All right, so that's good enough for now. Now we need to think about actually that minus cosine of x here for a second, you can see that it was starting off here at 0, comma, minus 1. Okay, and more importantly though, it was actually starting at the bottom of the wave. Okay, the bottom of the wave. So the x value that we're going to start off with because of our phase shift is going to be minus pi over 6. And again, we want to end up at the bottom of the wave. Well, if the middle of the wave is at y equals 1 and the amplitude's 2, then the bottom would be down here at minus 3. So this is where we'll start, okay? The bottom of the wave. There we are. Now, next, you see that the next quarter point, you should be at the middle. Okay? So our next quarter point was actually at x equals 0. I'm going to go ahead and put a dot there then. And then we should end up at the top of the wave. Since our amplitude was 2, that should only be 2 units up from the middle. So 1, 2, only puts us to y equals 1. And then the next one, we should be back to the middle, and then to the bottom of the wave, and then back to the middle, and then back to the top. Okay. And so once you do get the hang of this, honestly, the hardest part is just filling in the x and the y axis with the tick marks. Once you're done with that, we're really kind of sketching the same pattern over and over. It's just been shifted in different directions and maybe stretched or compressed. Okay, there it is. And now the question is, well, have we sketched 2 periods? And the answer is no. We could see maybe right now that this right here is 1 period of cosine, or 1 period of our function. Okay. And again, you can look at the parent function and see, oh yeah, we have made that same shape there, but we haven't made it twice, so we only have 1 period. So we're going to need to add maybe a couple more tick marks here. All right, so after the 5 pi over 6, that was going to put us at 6 pi over 6, which is just pi. And if we go another one, we'll be at 7 pi over 6. And I think, let's see, next would be at the middle and then the bottom. Yeah, that should complete 2 full cycles or 2 periods. So here's the middle and then the bottom of the wave. All right, so there's 2 full periods. And if you're ever unsure of whether you've sketched 2 full periods, well, if you just take your endpoints, so your right endpoint minus your left endpoint, this is actually going to tell you how far apart those endpoints are. So if I subtract these, that gives us 8 pi over 6, which is 4 pi over 3. So the question is this number here double what the period was? Okay. Well, we had the period was 2 pi over 3. So if you double that, you get 4 pi over 3. So we have sketched 2 full periods.